Let's take a look at how to use the quadratic formula. Now here's an equation, 5x squared plus 8x plus 3 equals 0, that we could very easily try to complete the square on. First thing we'd have to do is divide all of our terms by 5, and we would end up with x squared plus 8/5 of x plus 3/5, and that's equal to 0. And right here we can already see that, yeah, we can still continue completing the square. We can take half of 8/5, which is 8 tenths, and then square that, which is 64 over 100. We'll end up adding that over here while we subtract that over there. And notice that with the fractions, it's going to be a little bit of a mess. So, yes, completing the square can work here. But whenever we have a coefficient greater than 1 for x squared, if it's not easy just to get rid of it, then why not just go ahead and use the quadratic formula that we just finished proving in the last video. In order to use the quadratic formula, I have to make sure that my equation is in the standard form, which is ax squared plus bx plus c is equal to 0. Then I have to take a moment to identify what my a term is, what my b term is, and then what my c term is. And in this case, my a term is 5, because that is the coefficient here of the x squared. My b term is 8, because that is the coefficient here of the of the x term, and my constant term, or my x to the 0 power coefficient, is 3. And now it's just a matter of substituting these values in to the quadratic formula that we proved in the last video. So we would put the opposite of 8, or negative 8, plus or minus the square root of, let's go ahead and do this, 8 squared minus 4 times a times c. All of that is over 2 times my a term. So that's substituting into the quadratic formula. That's x is equal to all that. And now it's just a matter of using our order of operations to simplify. So negative 8 plus or minus the square root of 64 minus 20 times 3 is 60, all over 2 times 5 is 10. Or negative 8 plus or minus the square root of 4 all over 10. Or the square root of 4 is 2, so that's negative 8 plus or minus 2 all over 10. So what we have is two values. X can be negative 8 minus 2 over 10, which was our lower valued root. But x can also be negative 8 plus 2 over 10. In which case, negative 8 minus, that'll be negative 10 over 10, or negative 1. So x is equal to negative 1. In the other case, negative 8 plus 2 is negative 6 over 10, or negative 3/5. And those are my two roots.